Right, hello, my name is Jishan Chowdhury from JC Tuition, and today we're going to be talking about some A-level maths and specifically about simplifying expressions of a cos x plus or minus b sin x expressions in this form. So you can simplify expressions in this form to something that looks like this, either r sin x plus or minus alpha or r cos x plus or minus beta. And why would you want to do this? Why would you want anything in this form? Well, clearly this is cos x and sin x, and when we work with both, it's really hard to illustrate and visualize. But when we can bring it down to just one term of sine or cos, well, we can draw sin x, we can draw cos x, and hopefully you know how to do that from your previous sort of studies. And for instance, if we know sin x, well, we know that alpha is just the horizontal translation of the graph and r is just the vertical translation of the graph. So we can visualize things and actually apply what the expression means, and we'll hopefully see an example of that. And so how do we go about doing this? Well, like I said, I'll take you for an example, but if we were to just sort of put it in a nutshell, what we do is we use the addition formula to expand either r sin x plus minus alpha or this r cos x expression. And then we equate the coefficients to our initial expression and just solve the unknowns. If you're unfamiliar with the addition formula, I'd recommend you learn it, but essentially this is it. And what we're doing is we're basically taking the right hand side and trying to turn it into the left hand side because it's much cleaner, much simpler, and like I said, you can visualize things and do things with it. So let's do an example. So this question, we've got a function of theta equals 12 cos theta plus 5 sine theta. Now we just write the function of theta in the form r cos theta minus alpha. So firstly, let's write the function of theta and equate it to this. So we've got 12 cos plus 5 sine theta equals r cos theta minus alpha. Okay, and then what we said we'd do next is we'd expand r cos theta minus alpha using the addition formula. So using what I gave you in the last page, and then just multiplying each term by r, we get that r cos theta minus alpha is equal to r cos theta cos alpha plus r sine theta sine alpha. Okay, so we've just used what I gave you in the last page here, this expression down here, and we just multiplied each term by r because we've got an r in front. Okay, so now what we do next is we equate the coefficients. So if we compare, I'll do this in a different color. If we compare this 12 cos theta to this r cos theta cos alpha, well, the cos theta, if we compare that, they're both there, but this r cos alpha is essentially replaced by the 12 here. So we can see that this hasn't got an r cos alpha in this expression. Instead, it's replaced by a 12. Similarly, we've got a sine theta here and a sine theta here, but this 5 is not down here, and the r sine alpha is not up here, so they must equate each other. R sine alpha must equal 5 and r cos alpha must equal 12. So I'll go ahead and write that down. R cos alpha equals 12 and r sine alpha equals 5. And now let's rearrange for sine alpha and cos alpha. So we get this follows that. Cos alpha is 12 over r and sine alpha is 5 over r. Okay, now we can solve for alpha because as we can see we've got trigonometric expressions. So let's draw a right angle triangle. There we go. Terrible triangle, but that will do. Now remember our SOHCAHTOA, you should remember from our GCSEs. So for cos, we've got cos is adjacent over hypotenuse. So if we make this angle alpha, so adjacent is our angle 12 and hypotenuse is r. And then we can use this, the other edge, we can fill it in by using this expression here. So we've got sine alpha equals 5 over r. Sine is opposite of the angle, so 5 over hypotenuse, which is also r. And now, by no surprise, hopefully, we're going to work out r using Pythagoras' theorem. So r, therefore, equals square root of 5 squared plus 12 squared. So that's 144 plus 25. So that's root 169, and that equals 13. So actually, if I were to give you a general expression to work out r, you can just do r equals whatever this term is squared plus whatever term this is squared and square root it. So the general form for r is just the square root of a squared plus b squared in our generic form. If you wanted a little shortcut and didn't want to draw out the whole triangle. All right, cool. So we worked out r, and now we need to work out alpha. So I'd need a bit more space. I'll draw a line here. So continuing this, so we've got two expressions here: r cos alpha equals 12 and r sine alpha equals 5. Well, clearly, if we divide, let's say this is equation 1, and divide it by equation 2, we can eliminate the r and solve for the alpha. So let's do that. So if I put equation 1 divided by equation 2, well, we've got r sine alpha equals 5 divided by r cos alpha, which equals 12. So divide that by 12. And the r's cancel out. That's fine. And hopefully you can notice that sine alpha over cos alpha is tan alpha. So you should be familiar with that expression. It's tan alpha. That equals 5 over 12. And now we can take the arctan of each side, and that will give us a value for alpha. So alpha equals tan to the minus 1, 5 over 12. And if you plug that into your calculator, you get a value of alpha as 22.6. And so now we've got an alpha and r. So finally, therefore, we can fill in this expression of and replace r and alpha with the value we just figured out. So r is 13, and it's just cos theta minus 22.6. So that is how you go about simplifying these expressions, and you can do it with any of these double angle these addition formula. Okay, fine. Let's do part B. So that was part A worked out. Now let's do part B. So part B is asking us to find the maximum value of the function of theta and the smallest positive value of theta at which this occurs. So it's actually very useful that we were able to bring it down to one expression, as I was saying earlier, because we can actually visualize the graph. We know the cos graph looks something like this. So it starts at 1, comes down, goes up, comes down, and its maximum is at 1 and its minimum is at -1. So we know the maximum, say maximum, is when so if we just ignore the 13 for a second, and I'll do this in a different color. So for cos theta, it doesn't matter if it moves left or right. I know there's a translation left or right. It doesn't matter because the height, the maximum will still be the same, which is still 1, right? If you imagine I shift this graph left or right, it doesn't matter. The maximum will still be 1. So the maximum is when that expression cos theta minus 22.6 equals 1. Okay. So if we make that equal to 1, well, we've just got 13 times 1, right? So we replace all this what's underlined in green. We replace this as 1. So 13 times 1 is 13. So the maximum height, the maximum value of f theta equals 13. All right. And we're also asked to find the smallest positive value of theta at which this occurs. Well, when cos theta take 22.6 equals 1, we can take the arc of the arc cos of each side, and we're left with theta minus 22.6 equals, well, when you plug that into your calculator, you get, well, you don't even need to plug it into calculator. We can have a look what happens when cos equals 1. Well, we know it equals 0. We know it again goes down at 90, 180, 270, and meets the maximum again at 360. We could also go the opposite way. It obviously goes down and up, and again it will meet the maximum one at minus 360 as well. So there's a few values it can take. We just need the smallest positive value. So the smallest positive value is clearly, well, 0. Well, 0 is not a positive number, but when you add the 26, if you add 22.6 to it, well, we got theta equals 0, add the 22.6 is 22.6 degrees. So that's the smallest positive value at which this occurs. Okay, I hope that made sense, and you can now simplify expressions in the form of a cos x plus or minus b sin x. Okay, goodbye.